Okay, today we have 4.3 for the trigonometry. Now, after 4.1 and the 4.2, I think all the concept, most of the concept we already learned. And today, I would like to focus on do the calculations. So if you have more conceptual question, you want to go back to review 4.2. And then if you still have more question, you may ask me in the class time. And today, I would like to help you with how to use the concept to do the calculations. Now, first, I would like to review one formula. It's a very special triangle. We call this triangle is right triangle, and one angle is 30 degrees. So if you have 90 degrees here, 30 degrees here, this angle need to be 60 degrees because three angle plus together need to be 180 degrees. Okay, so in other words, if you have a right triangle, then you have two acute angles. These two acute angles are complementary. So, in other words, for any one right triangle, if you have one angle called alpha, the other angle measure is beta, then the measure of angle alpha plus the measure of angle beta need to be 90 degrees, or we say is pi over 2 radian. So that's very important concept here for the right triangle. Now, when we are talking about the sine cosine function, I would like to use the very special angle called 30 degrees and the 60 degrees here. Now, when we talk about sine cosine, we base on which angle? When we talk about sine cosine, we base on this angle. Okay, not this angle. We base on 30 degrees. Now, if we want to talk about the reference angle is 60 degrees, then you need to redraw. You need to draw another triangle. Then this will be 60 degrees. And this becomes 30 degrees. So if you are talking about the purple triangle, then you are talking about the 60 degrees. This is 60 degrees. Okay. If you are talking about the red triangle, then the reference angle will be 30 degrees. Next, I want to talk about if we talk about sine function. Sine 30 degrees will be the y value here. If this is a unit circle, if 0, 1, pretend this is the unit circle. Then the y value will be sine 30, and the x value will be cosine 30 degrees. Now I would like you to take a look the purple triangle. the purple triangle, the sine value is sine 60 here, right? And the cosine value, cosine 60. Do you notice that cosine 60 happen to be equals to sine 30? Why? Because on the same unit circle, cosine 60 is adjacent to 60 degree, but actually is opposite to 30 degree. So the opposite value to the 30 degree will be sine 30. So these two need to be equal. Okay, so because this 60 degree become here, so the opposite side here, opposite side here become adjacent side to the 60 degree. Okay, let me redo this. So the adjacent for 60 degree equals to opposite side of 30 degree. So this opposite. And then this side is adjacent to 60 degree. So the definition of sine function is opposite to the reference angle. And the definition of the cosine function is adjacent to the reference angle. Now, my picture kind of like a little messy, so I would like to explain these two one more time. We still have more space. So one more time. If you have 30 degree and 60 degree, if we call 60 degree is the reference angle, then opposite to the reference angle. Opposite to the reference angle is sine. And the adjacent to the reference angle is cosine. Now, if you move this triangle, you tilt this triangle to this way. So this 30 degree become here. This 90 degree, this should be 60 degree. Okay, so this 60 degree goes to here. Now, the reference angle will be 30 degree. If the reference angle is 30 degree, then the opposite happen to be adjacent to 60. So opposite of 30. Opposite of 30. Basically, the opposite of the 30 happen to be adjacent. So opposite angle 30 equals to adjacent of angle 60. Right? and the adjacent of angle 30 happen to be opposite of angle 60. And these two values should be equal. So in other words, adjacent means cosine 30 should equals to opposite of the 60 degree is sine 60. And we mentioned these two acute angles in the right triangle, they are complementary. So if two angles are complementary, means in other words, we say 60 equals to 90, take away 30. Or you want to say 30 degree is 90 minus 60. So if we have this special situation, if you have alpha equals to 90, take away beta. Or you have beta equals to pi over 2 minus alpha. Remember 90 degree. Sorry, I don't supposed to do that. If this degree, okay? And then let me change it to, sorry. If I say theta radian and the t, when you have radian, you don't use degree. Okay, so and the sine function, cosine function is so special. If two angles are complementary, then if two angles plus together is 90 degrees, we say it's complementary. Then sine theta will equals to cosine t. Or you say cosine theta equals to sine t. Because the opposite become adjacent, adjacent become opposite. Okay, but right now we would like to write down, become a formula. How we write down? Pay attention here. If you decide to use theta or you decide to use t, you can solve for theta or t in terms of the other data, right? So right now I would like to use this one. Theta equals to pi over 2 minus t. So you change theta to pi over 2. Let me change other color. Sorry. Okay, let me rewrite. So in other words, I can say that sine, instead of write down theta, I will write down pi over 2 minus t equals to here cosine t. Or cosine, instead of write down theta, I write down pi over 2 minus t equals to sine t. So this is the formula we want to learn for today. Once you understand sine, cosine, they have this property, then it becomes a formula to us. And if two functions has this property, we call these two are co-function. And if you change the angle by these two angles are different by 90 degrees, then and also they have this property, then we call sine and the cosine are cofunction. And I would like to formally introduce sine function, cosine function, tangent function, and we pay attention on our name. The name always involve cofunction idea. Okay, so let's keep going to number 1. Number 1, when we talk about sine, we just write down S-I-N. We don't write down S-I-N-E, but the full name is S-I-N-E here. Okay, but the function symbol we just use S-I-N without E. And the input, you input the angle. So we read sine of theta, or we say sine theta, then that's fine. Now pay attention on cosine. Cosine, we don't write down cosine, the whole thing. We just say COS. And the input is the theta angle. Now we pay attention on them. Cosine. Do you see that? Cosine. So obviously, by the name, these two are cofunction. And the definition of sine function is the opposite divided by hypotenuse. In the circle, it's the radius. In the circle, hypotenuse will be the radius. And the definition of the cosine function is adjacent divided by hypotenuse. Okay, so that's definition, and follow those definitions. These two functions are cofunction. Next, tangent. Tangent is the definition is opposite. Opposite over adjacent. Now, if you have another function is adjacent over opposite. Okay, so this we call tangent. And if I make a reciprocal, these two exchange. Remember, if you exchange opposite and adjacent, they become cofunction. Why? Because this angle is pi over 2 minus theta. So, if you are talking about adjacent over opposite, basically, if you say tangent pi over 2 minus theta, if your reference angle is this angle, then actually the opposite will be this one. And the adjacent will be here. Okay, so tangent pi over 2 minus theta on the original graph, you may have adjacent over opposite, or we say opposite over adjacent when the reference angle is pi over 2. It's kind of a little, let me see. Let me use the right color so it won't confuse you, okay? Okay, so if we talk about the reference angle, is this angle. Then opposite over here, right? If I call this 9 is green, okay, this green, okay. I call this is A. And then let me call this one is B. So you don't need to worry about opposite or adjacent. So if your reference angle is pi over 2 minus theta, then opposite will be the green color A. Okay? And the adjacent to pi over 2 minus theta will be B. So let me use the right color, B. And then we divide here. Okay? Now, A over B, you may also say if we're talking about the reference angle is theta. So you may say if the reference angle is theta, what happens? Wow. If reference angle is theta, we cannot use tangent. Why? Because, sorry, then this, where's this? Tangent theta. If this is the reference angle, then opposite will be the purple. Here, purple color, B. And the adjacent will be the green there. Now, obviously, do you see these two are reciprocal? So we have another name. Since they are reciprocal, we have another name for the cofunction, right? So we say cotangent. Cotangent. Cotangent theta. Because they have the cofunction property. Okay. So the reciprocal of adjacent and the opposite side, we give it a special name called cotangent. Now, let's take a look. Cotangent here. So this is cotangent. Cotangent, why is the reciprocal of the tangent? Because when we are talking about the tangent, we are talking about simply these two, right? So it looks like a T, tangent. So tangent function is just talking about opposite and adjacent. Therefore, if you make a reciprocal, you are going to have cofunction because opposite become adjacent. Right? If I change it to let me use the right color. Sorry, I would like to use the right color. Okay. So if I one more time, if I use reference angle here, then this will be opposite. this will be adjacent. And if I talk about the other angle, 90 minus theta, then this become opposite, and this become adjacent. So the fraction will be just reciprocal to each other. Then we go back to sine, cosine. So we talk about sine function and the cosine function because they are co-function. Because they are co-function, therefore they have the name cosine and the sine. And then keep going. And then we talk about tangent already. Now, two more. Cosecant and the secant. Secant, by the definition, is the reciprocal of cosine because the definition is just the reciprocal. Okay, cosine definition adjacent over hypotenuse, and right now reciprocal. So it's easier to memorize secant and the cosecant. Okay. Why they are still co-function? Because sine and the cosine are co-function, and their reciprocal will be the co-function as well. So after we are done with all the concept, then we kind of go through the formula here. Co-function, co-function. Okay. So remember, this is cosecant is 1 over sine. Let me review for you. And the secant is 1 over cosine. And the sine, cosine, they are co-function. Therefore, secant, cosecant are co-function as well. And then tangent, cotangent, they are co-function. So number 1 and the number 2 basically is talking about if two angles are complementary. Complementary means two angles plus together. These two angles differ by, now these two angles plus together is 90 degrees. So that's number 1, number 2. And then number 3, new definition. If you have your eyes, your beautiful eyes, okay, you take a look, or your eyes, you want to take a look going down, okay, and we said this is the level of your eyes. This is the level of your eyes. And if you look up or look down, when you look up, we say it's elevation. And when you look down, we call it depression. Okay, so just a name. And then we are going to use these two vocabulary words for the word problem a lot. Okay, so before we use those two vocabulary words, we want to practice with how to find the value, evaluate for all the functions value. So remember, you need to memorize the definition of each function. This is opposite over adjacent. Opposite over hypotenuse. Not good writing. And this is adjacent over hypotenuse. And the tangent will be opposite over adjacent. And then cosecant will be the reciprocal of sine. So you just make it upside down. You are fine. Okay. And the cosine, secant is the reciprocal from the cosine. So you just make this one upside down. H over A. Okay. And the cotangent is the reciprocal of tangent. So it's A over opposite. Adjacent over opposite. O P P O S I T E and A D J A C E N T. Okay, these two. So if the reference angle is theta, then this opposite. This is adjacent. This is hypotenuse. And because this 90 degree here, we follow the Pythagorean theorem. Therefore, if we don't know the length of this side, we say x squared plus this is 8 squared equals to hypotenuse squared. A squared plus b squared equals to c squared. So by calculation, equals to 17 squared minus a squared. I show my work here. Okay. So x equals to 15. So this adjacent equals to 15 and the opposite equals to 8. Therefore, you may easily plug in your answer. Sine is opposite over hypotenuse. A over 17. Adjacent is here, right? Adjacent over. So you can just do it. Follow the formula. I will let you try by yourself. Then one more example here. Wow, it's more calculation. Okay, so I will make another video starting from, what's the question number? Starting from number 5. Okay, so see you next video. Bye.